Yeah, my name is Tim Fischer. I'm co-founder and CEO of LabFly. LabFly is a medical drone delivery service. So medical logistics are slow and inefficient, and that's what we want to change. So our mission is that we want to help 26 million older people who are living in rural Europe, who can benefit from our fast, reliable delivery of medical goods via automated drones. With that, we are working on the SDGs, good health and well-being, infrastructure, and climate action. So our solution is a traffic-independent, automated, and electric-powered drone delivery service. The key features of the LabFly is always available courier service at your doorstep. We can transport 1 kilogram of payload over with 6 liters of payload volume. We have ultra precise localization built into the drone. Ultra fast delivery time or deliveries can be made with 60 kilometers of per hour flight speed, and we have 40 minutes of flight time, which is a range of 30 kilometers. The drone itself is completely developed by us. It's unique in the looks due to its good aerodynamics. A lot of features are built into the drone, like fully redundant propulsion system. So we have 8 motors, just need 4 to fly. We have 2 battery packs working in parallel. Um, we have a very safe flight controller, a safety computer, and also a rescue system built into the drone. So the use cases we're working on is hospital logistics, where we deliver lab samples and medicine between hospital and hospital, or hospital and laboratory. There we work together, for example, with the Charité Berlin, which is Europe's largest research hospital, and other customers. We also work in the field of pharmacy logistics, where we deliver medicine from the local pharmacy to the patient at home. There we work together with 6 different pharmacies right now in Germany. So the business model behind the LabFly is a delivery drone, uniquely designed for the transportation of medical goods, made in Germany. We offer it as a business-to-business drone as a service. So the LabFly delivery is as easy as Uber Eats, operated from Berlin. The whole operations are approved by the LBR to the EASA standards, and we are allowed to do BVLOS flight operations above populated areas within Europe. So the customer profiles who we're serving are medical logistics working in hospital groups within Europe with the need of fast, traffic independent and eco-friendly transportation of lab samples and medicine, and pharmacists in suburban and rural local pharmacies who need automated, contact-free and safe delivery of medicines from to the patient at home. So our vision is reinventing medical logistics in all regions. And now I have a short video showcasing how the LabFly is delivering a medicine from a pharmacy in Dessau, East Germany, to the patient. So the drone flies fully automated. It is the operator is supervising the drone from our office in Berlin, and he can operate the drones in all over Europe from there. And for the delivery of medicine, we just drop the medicine in the backyard of the customer. For the delivery of lab samples and medical goods between hospitals, we have a second version of the LabFly, which has an upper payload compartment, which then just lands at the location, and it's easy to operate. So in Q3 this year, we're going to raise our seed investment round. If you're interested in that or learn more about LabFly, get in touch. info@labfly.de. My name is Tim Fischer, and I was LabFly from Berlin. Thanks a lot.
Thank you very much, Tim. Next up, we are waiting for the team of FlexTech Not sure they arrived yet. So if not, if no one from LexTech is there, I think we're going to move on with another startup. And I'm going to call Space Locker. I'm going to be back. So next up, Space Locker. Thank you, Sophie.
What? Okay. All right. Well, good afternoon, everyone. So my name is Théophile Lagrolet. I'm the CEO and co-founder of Space Locker. At Space Locker, we are developing a service of turnkey space mission. The idea is really to enable an easy access to space for people that have a payload, have a sensor, have an experiment, and want to fly it without developing a full satellite. So our solution is really to develop a shared payload hosting. What does it mean? It means that our customer that has an experiment to fly, such as a sensor for Earth observation, such as an experiment of telecommunication, of IoT, or anything that would necessitate, currently need a spacecraft to be flown, will just come to us. We'll give him an interface, a standard interface that covers thermal, electrical, mechanical, and data transfers. And then we'll use this interface to plug it onto a satellite. So we plug those clients on two types of satellites, on our dedicated satellites, our dedicated missions, shared satellites, where we buy the satellites, we adapt it, and then we fly it, or onto as a secondary host on dedicated missions that has already a first primary payload, such as, well, let's say a telescope, and have a small space left. And currently, it's a huge pain for the industry to, well, adapt to a small customer that would fly next to that big telescope. And therefore, we are arriving with our interface. We adapt this interface to the satellites, take the complexity of adapting that, and then we plug our customer there. And therefore, we have a huge flexibility because we develop a full space catalog, let's say flight opportunities catalog, that enables us to fly any payload of less than 200 kilograms on any orbit. So the advantages of that is that it's truly responsive. So you're very quick to get in orbit. So currently, to get to orbit with a dedicated satellite, with the smallest satellite on the market, let's say you have 1 year of delay because you need engineering services, you need to prepare your mission, and most of the time it's mostly around 2 years because you really need to prepare that mission. With us, we are around 6 months of delay, and in the shortest way, we around 3 months because we really have a very responsive integration. On the other side, we are very powerful because when you're flying your dedicated mission, you're like stuck on your platform. You're stuck on your small platform. And what we do with shared satellites is that you benefit from a whole satellite, another class of satellite, a bigger one. It's 4 to 10 times bigger the satellites you would have flown. And therefore, you have the resources for your payload. You have resources that are 10 times higher in terms of peak because you share the platform. You share the platform, and you just have like, if you need a peak of telecommunication, you need a peak of power, you need a computation services on board. Well, we have those services, and we can sell you like at the right moment when you need it, and not you don't have to dimension the whole satellite for just like 30 seconds of processing, for instance. And then you have two other advantages that are very important for us, which is being cost efficient. Currently, launching a mission is too expensive. You have a huge capex. You need to put millions on the table to have your own satellites, and we are flattening those costs because we have a subscription-based model that have a first the first ticket that just needs to be paid in order to book your flight, and then you have a subscription monthly regarding of what you use on board the satellite. So you really have this pay as you use model, which is extremely innovative in the space industry. And last but not least, we are a sustainable solution. And we don't want to do greenwashing here. So that's why I put it in the last place, because it's important, but we still launch satellites, so we still have a bit of pollution, and that's a need to observe the Earth. We always need to remember that half of the data that we have to monitor the climate change is gathered by satellite data and is satellite data. So it's very important to have satellites, but we have an issue. We have an issue because satellites are not optimized. We are reducing the mass by 2, and we are gathering the debris in orbit, and therefore you have less orbital pollution. You have less debris because you have a much more controlled way of ending the life of the satellites, and you have less pollution on the launch because you launch less, like the mass divided by 2. Well, concretely, how does it work? As explained, our customers come to us, they build their payload on the interface that we give them. Then we plug that interface, we plug that payload on the green part that you see here, which is a receiver interface on the satellites and the host satellites. And then we launch the satellite with any launcher on the market, and we operate that satellite. That means that we tell the satellite where to point. We manage the satellite itself, the platform, the hosting platform. And behind it, the customer has a direct access to his payload. So he has a direct link to the sensor that is actually generating the data. He can download this data. He can monitor how is it going. He can plug it to his ground segment analysis pipeline. And so it's a really streamlined process with a simple dashboard, APIs and stuff. And so you have your own dedicated virtual machine on board, which is kind of from like currently a satellite is really considered as a separate asset with an old style approach of it. We are trying to implement the approach of the cloud computing that has been enabled on the and implemented on the data centers, but plugging directly it on the satellites. So putting the ground segment on board. Regarding the use cases, you've got many use cases. We are flying any mission that already flies today on any satellite, so we can cover any small sat. The first one and the simplest one is the technological demonstration. People that want to certify an equipment because then it needs to be sold and you need to verify that it works. You have people that do science, such as space agencies, laboratories. You have people that need to generate data because more and more you have a diversification of the data uses. You have people that use Earth observation data to monitor climate change, to monitor infrastructure, to survey to survey their supply chain, to connect houses. Well, you have a lot of private companies that need space data currently, and we are flying their sensors. The last one is also that we need to survey space. We need to observe space to monitor debris that flows. And so we need to we enable the fact of having sensors in space, and that's it. Regarding the technology that we use, as I said, the interface is really a key here. So we are developing an innovative and proprietary interface that covers thermal, electrical data exchanges. And so that's really a turnkey innovation here. A milestone. And then on the ground segment, we have also an important work on how can we make the satellite operation as seamless as possible for the customers, such as any player, even not from the space industry, such as, I don't know, you take Vinci, you take Bouygues, you take Nestle, that needs to, in 5 years, 10 years maybe, will need to monitor his assets from space, will be able to use our sensors without being a space player. And that's something that is changing totally the access to space and the way that people can think of using space. So we are currently raising. So if there is any investor here, let's have a chat. And on the other hand, we are currently opening our first booking for our first mission in 2024. So we have flight opportunities that start in 2024, and that will be going on in 2025, 2026. So, we are looking for customers. Last point, because I see that there's a lot of young faces here. We're also hiring young and not young people. So we're hiring a core technical team to enable us to scale those activities. So feel free to come to talk to me at the end of this speech. I'll be pleased to answer your questions. Yes. Je sais pas s'il y a des questions. Yeah.
Hi, thank you for the pitch. I have 3 questions. One is the sustainable piece, if you could expand on that. Secondly, the traction, the market traction. And then 3, how much you're raising and what's the use of funds?
So, in order, the first one regarding the sustainability. So there are 2 things. The first one is that we reduce the mass of the satellite launch, and therefore the launch emissions are proportional to the mass you send. So, well, if you have a small satellite, you have a smaller launcher, and therefore you have less emissions. So that's the first point. That's an easy one, let's say, because when you have 4 payload plugged on one satellite, instead of 4 different satellites, you mutualize those like the systems. Solar panels, you don't have 4 times the fast solar panels, you don't have, and so that's the first point. It's important. And then the second one, which is actually, I think, the main concern regarding the space industry today, it's the debris. Like we're talking about a lot about debris in space and like the Kessler syndrome and stuff like that. And so we are working on that in several points. The first one is reliability. As we gather several that would have flown on a small satellite, which would be really less reliable than the big one that we fly, we have this improvement in terms of reliability, which means that you have a less, you have a lower failure rate. So that's mean less debris first. And then when you have, for instance, when you have a customer which is 10 centimeter high, it flies on a 20 centimeter satellite, so it's very small. And therefore, at the end of the mission, it's kind of an uncontrolled end of life period. And when they're gathered on, when you have 4 of those customers on our bigger platform, or 10 of those customers, you really switch from a category to another in terms of satellite and support systems, and therefore you really control the end of the life of the satellite. So you have those 2 things. The second question was regarding, the market traction. So we're launching our first mission. We have 4 slots on board for customers, and for those 4 slots, we currently have more than 4 interested players. We haven't signed yet contract because we just opened the reservations, but we're quite confident on the fact that we will have at least 2 contracts signed by the end of the year, 2 first customers, and maybe more. We'll see. And the last point regarding the amount raised. Currently, we are in a pre-seed round. We're raising 400K in equity to close a 1 million total round, which will be leveraged by like public money and public investments. Right. That's it.
Thank you, Theo. Thank you very much. Thank you, Theo. Up next, we have Skyzen.
So good afternoon, everyone. My name is Jean Rial. I'm the CEO of Skyzen. The topic today will be about maintenance software, and I will start with the context. So the context today, when you buy an aircraft, it can be an helicopter, business jet, an airliner, or flying club aircraft. You have to follow a regulation, which can be pretty complex. And to manage this, the maintenance of the aircraft, you have tools which looks just like this, which is pretty old-fashioned now when we see the tools that we use every day on our telephones or anything else. So to develop such a tool is quite complicated, meaning that it's very technical. The regulations are quite complex. There is specific things depending on the operational context and so on. And the result is all the softwares are too expensive for small or medium operators, or are very not intuitive. So why I'm here today is to introduce you Skyzen, which is an online software, collaborative, and based on the last technologies, and is by design meant to manage mixed fleets. So it can be airliner, helicopters, light aircraft. It's full web, hosted on cloud, available anywhere you are on the world. It's currently used by 250 aircraft and in 7 countries. So the idea is to just have a simple software to manage maintenance activities for aviation. What our key benefits compared to the other organizations, the other softwares, is we have made it to be very intuitive. How? Because it's designed by the feedbacks of our customers. So when something is bad or not intuitive, they tell us, Jean, I don't understand how to use this feature. And with this direct feedback, we improve small step per small step. And at the end, we get something that is much more intuitive than the other organizations. And the benefit of this is it's easier to learn. So you save money on the deployment. It's much less painful for your teams to learn this new solution. And the support is reduced because they know how to use it. The other thing is it's full web, so on cloud, agile to support. If there is a small bug, in the next 24 hours, it can be solved, which is nice. It can be easily integrated with APIs to flight data monitoring solutions on the aircraft, or with ERP solution for the logistics side. And finally, it's collaborative, which means all the users of your organizations or in other companies can use the software, and you can work all together around one tool, and you can share the data, and the data is traced, and you have a full digital continuity. Today, we have customers in 4 different sectors: smaller airlines, such as Arc-en-Ciel Airlines, helicopter markets with Air Monaco, business aviation with Franconia service in Germany, and finally, flight school with Flugschule Basel in Switzerland. Our next steps are to continue the development of the platform, because as it's highly complex, there is always new things to improve. Develop our network of business providers worldwide. For the moment, we have a network already in Latin America, and to increase our footprint in the helicopter maintenance market, as we now have all the features to answer the needs. So what are we looking for the moment? As every company, we are looking for customers, which can be aircraft operators, CAMO organizations, or maintenance organizations. And we are looking for business partners, which can be OEMs, business providers, or advisors which know the maintenance business quite well, and which can help us to improve our solution. So if you have any question, I am available.